Okay, folks, section 11.5 says expected values. Okay. Now, the big idea that we want to get today is sometimes games can be fair or not fair. And expected values helps us determine if a game is fair or not. Okay? Now, this first comment says that some games favor one player over another. The fairness of a game can be measured by computing the expected values. Okay, now here's the important thing. To find the expected value for a player, multiply the amount won, like the points, by the probability. Points multiplied by probability. That gives us the expected value. Now, let me just talk to you about one real quick. Sydney, let's say that you and I were playing a game, all right? And I have a die. Now, a die is a singular, right? 2 is dice, 1 is die. Okay, I have a die, a number cube. It goes 1 through 6. Here's the game. If the die lands on 5, you get all the points. You get 5 points. If it lands on anything else, I get those points. 1, 2, 3, 4, or 6. Okay? Is that game fair? Raise your hand. Do you think that that game sounds fair? Chloe? It does not sound fair. Certainly, Sydney's going to get 5 points if it lands on 5, but it's only going to land on 5 1/6 of the time. 5/6 of the time, it's going to land on something else, and I get those points. We can measure how fair or unfair a game is using expected values. Okay? Let's look at the first example that they give us here. It says, a number cube is tossed, 1 through 6. If the number is odd, Judd gets that number of points. If the number is even, Megan gets that number of points. Find the expected value for a turn for each player. Now, before we do that, does this game sound fair to you? Raise your hand. Tell me if you think that this game is fair. And the easiest way is to say, would I rather be Judd in this game, or would I rather be Megan in this game? What do you think, Reed?
I think it's not fair because there's more even numbers than odd numbers.
Now, wait a minute. Are there more even numbers than odd numbers on a number cube? They're the same number of evens and the same number of odds. So Reed is partially right. But why is he right? It's not because there are more evens. There aren't more evens. Why is Reed right, Chloe?
Because the evens are worth more points.
The evens have higher point values. The odds are 1, 3, and 5. The evens are 2, 4, and 6. Okay? But we can actually show how unfair the game is. All right, let's do this. If the dice lands on 1, then we give Judd 1 times 1/6. But that's not the only thing. Well, here, let me work it out below. This will make it easier if we see it down here. All right, here's Judd. Judd gets a point if it lands on 1. But what's the probability? What's the probability that it's going to land on a 1? Well, 1 out of 6. But he also gets points if it lands on 3. But what's the chance that it's going to land on 3? 1 out of 6. Now guys, this video is going to end, and I'll have to pick it up again on the next video, but I'm going to keep going for a moment. Judd also gets points if it lands on a 5. But there's only 1/6 of a chance that it's going to land on a 5. Now let's find out what Judd's expected value is for every roll. We're going to simplify this, but I'm going to do that on the next video.